Hi, this is Darshan of Group 45. My roll number is B21249. We have been assigned to design a model to detect DDoS attacks using machine learning techniques we have learned in this course. These are the group members of Group 45. This will be the flow of a video. Now, let me introduce you to DDoS. First, what is DOS? Denial of service. The service provider of the internet, of whichever application or web page you're accessing, uses a server to offer that particular service of his or her. These servers, of course, have their limitations. These servers can handle only a finite number. This limitation can be exploited by any anonymous person to create false traffic and cause the denial of service. The main difference between DOS and DDoS attack is that in a DDoS attack, multiple compromised systems are used to target a single system, whereas in DOS attack, a single system targets a single system. This will result in a flood of malicious traffic, malformed packets, and connection requests that overwhelm the targeted system, thus denying service to legitimate users. There are mainly three types of DDoS attacks: application layer attacks, protocol attacks, and volumetric attacks. Existing methods for mitigation of DDoS attacks. While there are no proper methods for completely preventing a DDoS attack, measures can be taken to mitigate the attacks to happen. Some helpful measures are ensuring high levels of network security, firewalls, intrusive detection systems, endpoint security, antivirus, anti-malware software, etc. act as network security. Implementing them makes it easier to prevent or lower the risk of a DDoS attack to happen. Possessing server redundancy. This means to have multiple servers rather than having a single host server. This is a very efficient method because if an attacker targets a hosting device, other servers can still run and take on extra incoming traffic until the targeted server gets back online. Continuous monitoring of network traffic. The continuous monitoring gives an idea on the usual network activity and traffic patterns, making it easier to detect odd activity at an early stage and stop it. And the useful technique is 7. Selective and adaptive verification. It is a technique used to defend against DDoS attacks on the network layer.
Hi, this is Rishi Reddy Narayan. My roll number is B21306. I'll be continuing the presentation from here on. The aim of the project is to create a machine learning model that can detect DDoS attacks and predict the accuracy of attack detection with different types of machine learning algorithms. Coming to the objectives, first one is to analyze the data and its parameters and check any redundancies that might affect the prediction values. Then we'll be taking the necessary steps accordingly, such as removing all our empty uncertainty values, etc. And next we'll be using all different types of classifiers on data and predict the accuracy of detecting an attack. And coming to the approach used for the project, in this project we have taken a dataset that consists of several IP addresses of user and destination, the data transmission speed and memory, the time of source presence, etc. The data comprises a total of 23 attributes that are required for detection of a DDoS attack. We put this data in through several machine learning algorithms to successfully yield a DDoS attack and come to a conclusion to which of algorithms yields higher accuracy. The project was operated on KNN method, logistic regression, never-based, and clustering methods like k-means method and hierarchical clustering. Coming to the code implementation part, firstly we have imported all the necessary modules that are required, and we have read the CSV file using the pandas. And next we have determined the shapes to know how many rows and columns the data is consists of. Here the data comprises of 1 lakh rows nearly and 23 attributes, and we have represented the activity on websites with suspicious activity and normal activity using a donut graph. And here we have plotted horizontal bar graph for total number of non values in each attribute, so that we can remove them because this might affect the this might affect in prediction of a algorithm prediction of attack. And we have represented in horizontal bar graph determining number of users of true users and attacks from different types of IP addresses. And now we have determined a bar graph of total number of requests from different types of protocols, basically protocols of 3 types: ICMP, UDP, and TCP. Different types of protocols are used for different types of purposes, such as TCP is used for transmission, ICMP is used for sending messages, etc.
Hi, I am Tribhuvan. My roll number is B21173. Now I will be continuing the presentation from here on. So when a user enters a server, say some sort of website, the data regarding the user IP, destination IP, the duration in the website, speed and size of data transmission and such are stored in the website database. Now we'll be looking at the graphs plotted for such data. Here we can see the duration graph, and we can see that 250 seconds is like the most counted time in the service database. And looking at the transmission bytes, we can see that around 0.02 etc is the most counted database transmitted bytes. Now coming to the transmission speed, we can see that around 2000 is the most counted transmission speed for the speed. These such type of data are used for detection of an attack if it is ever going to happen. Now, a data set may contain several types of data like integers, floats, and strings. String data cannot be used for machine learning algorithms to train, so we'll have to drop them from the existing dataset. We implemented a code to display the types of data in our dataset. So we can see that our dataset has numeric columns and object columns. Numeric columns containing the integers and floats. So looking at the object columns, we can see that SRC, DST, and protocol are string data. SRC and DST are the server IP addresses, and protocol is the UDP and etc. that was discussed by Rishi. So we need to drop the three attributes from the dataset because we cannot use them for the machine learning algorithms. And after dropping the three attributes, we drop the null values and normalize the data so that everything falls under the same range. We then split the data into train and test data to fit for the machine learning algorithms. We plotted a covariance heat map to show you how the attributes are related. We drop the columns that have a correlation more than 0.7 to improve the accuracy of the models. Now Alex will continue the presentation from KNN method implementation. Thank you.
I'm Alex and my roll number is B21093. I'll now discuss the algorithms we have used in our project, that is the KNN and the k-means clustering. So KNN method, the k nearest neighbors algorithm is a supervised learning method of classification that uses the nearness, that is the distance of a point, to make a valid prediction about the grouping of the data point. Its working is as follows. Initially, we assign a k for the number of neighbors, then calculate the Euclidean distance of a new entry data point and take the k nearest neighbors to it. Among these k neighbors, we calculate the number of data points that belong to each category and then assign the new entry data point to the category to which the number of neighbors is maximum. This is the code we have used. So initially, we define a function and take the neighbors as 10, and we take a empty list, that is the test accuracy, and then we ran a for loop for in the range of 1 to the neighbors, that is the 10, and we are training the KNN data, and then we are finding the accuracy and then appending it to the empty list we have taken, and then we are plotting the accuracies based upon the k values we have taken. This is the plot, and then coming into k-means clustering. K-means clustering is an iterative algorithm that divides the unlabeled dataset into k different clusters in such a way that each dataset belongs to only one group that has similar properties. The goal of this algorithm is to minimize the total distance between the data points and their associated clusters by finding the optimal centroids for each and every cluster. So the working of the k-mean clustering is as follows. We initially take a k to define the number of clusters, and then we select the random k points, or also known as centroids. Then we assign each data points to the nearest centroid to get the predefined clusters, and then we calculate the variance and assign a new centroid to the cluster, and then repeat the following steps again. The ideal method to choose the value of k is by elbow method, but we have already observed the number of labels in our data to be 2, that is 0 or 1, so we can assign the value of k as 2. This is the code we have used. We are first defining the k-means function, and then we are defining the model for 2 clusters. So here we are predicting the data, and then we are calculating the accuracy, and in this case of k-means, we are getting the accuracy as 47.592. Now my teammate Anil will take over the project.
Hi, I'm Anil. My roll number is B21160. Now I'll explain the next algorithm, which is naive-based classifier. The underlying principle is Bayes theorem. In this algorithm, we assume two things. First one is each pair of features being classified as independent, and next is each feature makes equal contribution to the total outcome. So the formula of Bayes is posterior probability equal to likelihood into prior upon evidence. This is the derivation which we used in this problem. So here we can see that we assume that each attribute is independent of each other, and we have multiplied by, to get the to get the likelihood in this thing. So we take the maximum of parameter to get the maximum likelihood. So first we build a Gaussian naive Bayes model, and then we fit the data of the trained data. So from that we get we use the predict function to get the y predict, and we calculate the accuracy by using the accuracy score. And accuracy got is 66.8. We got less because some attributes are dependent on each other, so we get less. And next is hierarchical clustering. The hierarchical clustering approach that we implemented in our model is agglomerative. The agglomerative hierarchical clustering algorithm uses bottom approach to group the data sets into clusters. In this method, each data set is assumed to be a single cluster at the beginning. As the algorithm proceeds further, it starts combining the closest pair of clusters together. This goes on until all the clusters merge into a single cluster that contains all other data sets together. We stop this process when we get two clusters in the hierarchical clustering. So this is the code we used, hierarchical clustering. So we build the model from the given inbuilt function agglomerative clustering, and then we fit and predict the y predict, and we calculated the accuracy score and got the 54.38. And next algorithm is taken up by Aman.
Hello, this is Aman, and my roll number is B21046, and I'll be talking about logistic regression. So, logistic regression is one of the most popular machine learning algorithms, which comes under the supervised learning technique. It is used for predicting the categorical dependent variable using a given set of independent variables. So, logistic regression predicts the output of a categorical dependent variable. Therefore, the outcome must be a categorical or discrete value. It can be either yes or no, 0 or 1, true or false, etc. In this case, we have 1 as malicious and 0 as non-malicious. It gives the probabilistic values which lie between 0 and 1. So logistic regression is much similar to the linear regression, except that how they are used. Linear regression is used for solving regression problems, whereas logistic regression is used for solving the classification problems. Also, the main point is in logistic regression, instead of fitting a regression line, we fit an S-shaped logistic function which predicts two maximum values, 0 or 1. So the accuracy of the model is predicted on the basis of how well the curve is fit. And so how this is the code snippet, and here we we applied the logistic regression, and then we fit the training data here, and we predicted the y values, and also we returned the accuracy of the regression. So here we got the accuracy of the logistic regression as 73.28. So this is, as we come to the end of our presentation, we will conclude it. As we have observed, the KNN method of classification yielded the highest accuracy among all the executed machine learning algorithms with an accuracy of 91.63%. So as per the proposed approach, we can run the dataset of the server over KNN method to accurately predict whether a DDoS attack is taking place or not. A future model may consist of a hybrid approach comprising of 3 or more machine learning algorithms to produce a higher accuracy, as a result forming a very efficient DDoS attack predictor. Regarding the contribution, everyone of the group has contributed equally, whether it be in the code implementation or theoretical information. Thank you. Here are the references used for the projects. Thank you.